Hello, this is Tom from Tutor Bros. In this video, we're going to go over how to find the area of rhombuses and kites. You'll be happy to learn that the formula for the area of both figures is the same, so that's just one less thing you'll have to remember. And the formula is this. The area A equals 1/2 d1 times d2, where d1 and d2 are the diagonals of the figure. So since the formula is the same for both rhombuses and kites, and since it's pretty straightforward, we'll just do one example for each, and then we will call it a day. So we'll start with the kite that we see here on the right. You'll remember that a kite is a quadrilateral that has two pairs of adjacent sides congruent and no pairs of opposite sides congruent. So we'll take a look at the diagonals here, and we'll say that this little segment at the top is 2 inches. We'll just say inches for the sake of argument. This longer one down here is 5 inches. And then the one diagonal going horizontal is split into 2 segments of 3 inches each. All right, so we'll take all that information, we'll plug it into our formula, and then we'll solve for the area of the kite. So we'll say that A is equal to 1/2 times the length of each of the diagonals. Now, for our purposes, it doesn't matter which diagonal we pick for 1 and which for 2. It's pretty interchangeable. So let's start with the vertical diagonal, the one going up and down. That's split into 2 segments of 2 and 5 inches. So to find the total length, we just add those 2 numbers together. So it would be 2 plus 5. And then we do the same thing for the horizontal diagonal, split up into 2 segments of 3, so we just add those together, 3 plus 3. All right, then we simplify. Area equals 1/2 of 2 plus 5 is 7, and then 3 plus 3 is 6. And that equals, we can do 1/2 times the 6, since the 6 is even, so 1/2 times 6 is 3, times the 7 is 21. And we said that that's inches. So the area of this kite here would be 21 square inches. Pretty easy, right? All right, now let's do one for the rhombus that we see below. You'll remember that a rhombus is a parallelogram that has 4 congruent sides. So we can say that all squares are rhombuses because all squares have 4 congruent sides. But not all rhombuses are squares, because not all rhombuses have 4 congruent angles. That's just a side note there. So let's see what we can do with this one. We will say, I'm going to have to write kind of awkward here. So we'll say that this little segment here of this diagonal is 3 inches. And we'll say that this side length out here is 5 inches. And that's all we're given for this problem. Now, it doesn't seem like we have enough here. But if you remember some of the properties of rhombuses, we can actually find out a little bit more information. One of the things that we know about rhombuses is that the diagonals are perpendicular to each other. So we can put a little right angle symbol there because we know that that's a right angle. So let's stop there for a second and see what we can do with this information. Well, if we know 2 of the sides of this triangle that's created in the top of the figure in the rhombus here, what can we do to find out this portion of this diagonal? So I'll label it X for now. Well, you see that we have a right triangle and we know the length of 2 of its sides. So to find the length of the third side, we can use the Pythagorean Theorem. So 3 is one of the leg lengths, and then the X that we've labeled there would be the other leg length. And then 5 would be our hypotenuse, because that's opposite the right angle. Okay, let's use the Pythagorean theorem to find out what x is. So we can say that 3 squared, which is 3 is one of the leg lengths, plus the x squared, which is another one of our leg lengths, is equal to 5 squared. Alrighty, then we'll evaluate that. 3 squared is equal to 9, plus x squared, we still don't know what that is equal to 5 squared, which is 25. All right, then to solve for x, we subtract 9 on both sides, so then we would have x squared equals 16, and then we take the square root of each side, x equals 4. So now we've determined that this portion right here, oops, I'll just replace the x with a 4, so we know that that portion of that diagonal is 4 inches. Now let's go back again to some of the properties of rhombuses. We know not only that the diagonals of a rhombus are perpendicular to each other, but we also know that they bisect each other, which means that this portion of the diagonal is congruent to this portion here, and then this portion of the other diagonal is congruent to this one here. So now that we know that, we can plug in all this other information here. We can say that this length of this segment here of the diagonal is also 4 inches, and this one right here is 3 inches. So now it looks like we've got more than enough information to find the area of this rhombus. So let me just erase this here real quick. Alrighty. Then we'll start with our formula again. Area equals 1/2 d1 times d2. So area equals 1/2 of, and then we'll just pick one of the diagonals. Let's do the one that's broken up into the 3's. So it'd just be 3 plus 3 times the other diagonal, which is broken up into 2 segments of 4. So that would just be 4 plus 4. So then area equals 1/2 times 6 times 8. Then we can multiply the 1/2 by either of the two numbers since they're both even. Let's do the 6 again. So 1/2 times 6 is 3. 3 times 8 would be 24. So the area of this rhombus would be 24 square inches.